Hey, here we go. In this lesson, we're going to look for proofs that are not valid. So this is where someone's created a proof and there's an error in it somewhere. And usually these kind of proofs, we can kind of tell there's something wrong just based on what the statements are, what they're saying. Okay, they almost sound too good to be true. Okay, so here we go. So we're looking for things that might make our proofs invalid. All right, how do we do this? It's actually pretty easy. So consider the following statement: all students do their homework. Then the next student could be made Angie is a student, therefore Angie does her homework. Well, yeah, we got a bit of a problem. It's called a false assumption. We all know that all students do not do their homework, right? So this is what's known as a false assumption or a generalization. Okay, so sometimes the initial argument is incorrect, the initial conjecture or statement. All right, the other easy ones to spot: calculation error. So Liz claimed she proved -5 is equal to 5. So I mean, again, like I said, the initial statement is so crazy that you know there's a mistake in it. So here's what Liz is trying to prove. So she says -5 is equal to 5. So then what she does is she squares both sides in this line. And she says, well, -5 squared is 25 and 5 squared is 25. Therefore, -5 is equal to 5. Well, her mistake is in her very first step. Her first line is not true, right? That's false. So her original statement is false. -5 is equal to 5 is false. So the rest of what follows is also false. I don't know if I'd call that one, maybe that's like a very mild calculation error. I hope Liz doesn't think -5 is equal to 5. Okay. Another type is called circular reasoning. So it's an argument that is incorrect because it makes use of a conclusion that still has to be proven. Okay. So starting a proof by saying the thing you want to prove is true, right? So it just, you can't do that, right? You'll come across a couple of examples of those as you're working through the homework. And the last one I want to look at here is, again, this maybe falls better under calculation error, is division by zero. Okay, division by zero we cannot do, but it shows up when people are trying to make random statements. So this one here, 2 is equal to 1, and thus math is broken. Okay, I remember seeing this one in university. And okay, what do they got here? They start off with making statements. So they say x is equal to y. So I got two numbers that are equal to each other. Okay. Then they say, okay, let's multiply both sides by x. Done. And then they say, okay, let's subtract both sides by y squared. Okay, so they're maintaining equality. They haven't done anything incorrectly at this point. Then they say, let's factor both sides. And their factoring is correct. Then what they do is they divide both sides by x minus y. And it looks like they do this, right? They divide them, and then they can go on to prove that 2 is equal to 1. Okay, the error here is if x is equal to y in their original statement, then x minus y is equal to 0, and they are dividing by 0, which is not a defined operation. So this proof falls apart. So when you're looking at these things, again, you're just trying to poke holes in someone's arguments. And again, you could usually tell that there's going to be something wrong with the proof because they make some ridiculous statement like 2 is equal to 1. All right, friends, that's it. Go ahead, find some errors in some proofs.